Good day everyone, and sir, I'm Lawrence Samsero and I'm here to report about electrical machine. And first is introduction to AC motors and generators. An alternator or AC generator is a machine that converts mechanical energy into electrical energy in the form of alternating current. These are the workhorse of our modern world, found in power plants, vehicles, and various industrial settings. So, an AC motors and generators are important electrical machines used in everyday life and industries. An alternator or AC generator converts mechanical energy into electrical energy in the form of alternating current, while an AC motor converts electrical energy into mechanical motion. These machines are commonly used in power plants, appliances, vehicles, and industrial equipment. And next is construction of alternators. First is rotor assembly. The rotating part of the machine. It is built by stacking laminations and securing field coils. Rotors are generally classified as a salient pole of cylindrical or non-salient. And second is stator assembly. The stationary part, the core is built from insulated steel laminations to reduce AD current losses. Armature winding are placed into slots within this core. So, a rotor assembly, the rotating part of the machine that produces a magnetic field. It is made of laminated steel and field coils, and it can be either a salient pole rotor or a cylindrical or a non-salient rotor. And the stator assembly, the stationary part of the machine where electrical energy is generated. It is made of insulated steel laminations to reduce energy loss, and it contains the armature windings placed in slots. And next is diode rectifier and voltage regulator. These electronic components are mounted within the frame to control the output and convert AC to DC for the field coils if necessary. And next is bearing installation. Bearings are installed at both ends of the rotor shaft to ensure smooth, high-speed rotation with minimal friction. So, the diode rectifier and the voltage regulator, these components help control the electrical output of the machine. The rectifier converts AC to DC when needed, while the voltage regulator maintains a stable voltage. And the bearing installation, bearings are placed both ends of the rotor shaft to support smooth rotation and reduce friction during the operation. And next one is frame assembly, the housing that holds the stator and rotor. It includes end converse, cooling fans, and protective casing. And farthest laws, the fundamental principle. Here is the electromagnetic induction. When the rotor spins, its magnetic field cuts through the stator windings and inducing a voltage. So the frame assembly, the outer housing of the machine that supports and protects the stator and rotor. It also contains cooling fans and end covers and protective casing. And the farthest law, this law explains electromagnetic induction. When the rotor rotates, its magnetic field passes through the stator windings and produces electrical voltage. And now let's proceed to types of alternators. The first is salient pole alternators. These have poles that project out from the surface of the rotor, and the operation is best suited for low and medium speed applications like hydroelectric plants. The large diameter and short axial length allow for many poles. Here's the advantages and disadvantages of silent pole alternators. The advantages is simpler to construct and maintain and cost-effective for low-speed operations. And the disadvantages is high windage losses, air resistance at high speed, noisier and physically bulkier. And the application is for hydro power plants, low-speed diesel engines, and wind turbines. And the second types of alternators is non-salient pole alternators or the cylindrical. These have a smooth drum-like rotor where the windings are buried in slots. In the version designed for high-speed applications like steam and gas turbines, the smooth surface reduces windage and noise. And here's the advantages and disadvantages of the cylindrical. And the advantages is high mechanical strength for high-speed rotation, better flux distribution and quieter operation, and more efficient at high RPM. And the disadvantages is more complex and expensive to manufacture. Maintenance is more difficult due to the compact precision design. And the application is thermal power plants or steam turbines, gas turbines, and nuclear power plants. And here's the summary comparison table. And for the features, it have speed, prime mover, diameter, axial length, windage loss, and mechanical strength. And for the speed, the cylinder pole have a low to medium and high speed for the cylindrical. And the prime mover is wind turbine and or diesel, and cylindrical is steam or gas turbine. The diameter is for the silent pole is large and the cylindrical is small. And the axial is short, long, windage loss, high, low, and the mechanical strength is lower and very high. And for the additional essentials, excitation systems, the rotors needs help to become a magnet. This is done via an exciter which provides a small amount of DC current to the rotor windings to create a magnetic field. An asynchronous speed AC generator must run at a specific speed to maintain a steady frequency like 60 Hz to 50 Hz. And the formula is Ns is equals to 120 Xf over P. And that's all everyone, and sir, thank you for listening.